So radiation is, it's all around us. Doesn't just come from things that are radioactive, that we know, like uranium and plutonium and stuff like that, or the alpha, beta, and gamma sources that we've just looked at. It comes from all around us. So things like bananas and rocks, from travelling in planes, all sorts of background radiation. Yes, John?
How many bananas do we have to eat before it's
Millions, I would think. So radiation is all around us. It comes from food, rocks, radioactive materials, X-rays, etc. The amount of radiation in a normal room, like the room that we measured in today, like our classroom, so a normal room, not one in a hospital or somewhere that's got lots of radioactive materials, is called the background radiation. Now, there are three types of radiation that we've looked at today: alpha, beta, and gamma radiation. So we'll say that there are three main types of radiation. There are more types of radiation, but for the purposes of standard grade physics, we're just looking at those three. So three main types of radiation: alpha, beta, and gamma. An alpha particle is made up of 2 protons and 2 neutrons. Two protons and 2 neutrons, which we know, if you do chemistry, is a helium nucleus. So basically the middle of a helium atom. And that's where most of the mass in an atom is, in the nucleus. So the alpha particle is very, very big. So 2 protons and 2 neutrons. In fact, its energy can be absorbed by a sheet of paper. So because it's so big, it doesn't travel very far in air, its energy is easily absorbed by just a small sheet of paper. Beta particles, as you noticed in the experiment that we did, are slightly different. A beta particle is a fast moving electron. So the electron is a lot smaller than an alpha particle. It's a lot smaller than a nucleus. So it travels a little bit further. It'll travel a few meters in air as opposed to a few centimeters with alpha, but it's still quite easily stopped by something that's not too dense. So its energy can be absorbed by a few millimeters of aluminium, as we saw in the experiment we did. Gamma radiation, last of all. Gamma radiation is an electromagnetic wave, which is the reason really why it can travel so far through the air, and why it takes something that's really, really dense to absorb its energy. Its energy can be absorbed, although probably not completely. Some of it will still get through because it's so high energy, by a few centimeters of lead or concrete. So those are your three types of radiation, and that's what they're made up of. You need to know what you can put in the way of this type of radiation to protect yourself against it.